This is a lesson on proportion. In this video, you will learn about what is a proportion, the two kinds of proportion, direct and inverse, how to solve problems in proportion, and how to use K to express a proportion. What is a reciprocal, and how to solve problems in proportion using K. We first begin by looking at a ratio. Remember that a ratio compares two quantities of the same kinds, and usually of the same units. For example, the ratio of lengths and the ratio of weights. The order in a ratio is important. 2:3 is different from 3:2. A ratio has no units, and it can be written as a fraction. A proportion is two equivalent ratios. We have two kinds of proportion. Direct proportion, when two quantities are related such that when one increases, the other will increase along with it. And next we have inverse proportion, when two quantities are related so that when one quantity increases, the other will decrease along with it. Let us begin by looking at direct proportion. We use the example of library fines. As the number of days increases, the fines also increases proportionally. On the first day is 20 cents, the second day is 40 cents, and the third day is 3 times, and so on. If we were to form a ratio of any two corresponding set of values, for example, if we use 2, the corresponding value is 40, and 5, the corresponding value is 100, and if we form two ratios, 2 over 5, they will be equal. We can now find an unknown value, x, by forming two corresponding ratios, such as 2 over x, which will be equal to 40 over 520. We cross multiply. To get 40x equals to 1040, and x is 26 days. We now look at some more examples. In the next example, we have 8 pencils which cost 240. We need to find the maximum number of pencils you can buy with 540. We begin by writing two statements. 8 pencils cost 240 and X pencils cost 540. Again, we are going to form a ratio of the pencils, which will be equal to the ratio of the cost. We cross multiply to get 2.4x equal to 43.20 cents, and x is 18. Hence, we conclude that 18 pencils cost $5.40. Let us now look at another example. In this example, we have a man takes 2 hours and 30 minutes to travel a distance of 160 km. How long does it take for him to travel 280 km? Once again, we start by writing two statements. He takes 2.5 hours to travel 160 and X hours to travel 280. Again, we form the ratio of the time, which will be equal to the ratio of the distance. And once we cross multiply, and solve for X is 4.375. Again, we finish off with a statement. It takes 4.375 hours to travel 280 km. Now we will take an example of an inverse proportion. In this case, we are looking at the number of men and the number of hours he takes to complete a job. As you can see, when we have one man, he will take 120 hours. But when we have two men, he only take half the time. And when we have three men, he take only 1/3 the time, and so on. So as the number of men increases, the number of hours decreases. This is an inverse proportion. In an inverse proportion, if we look at the number of men and the number of hours and multiply them together, we will notice that it will always give us the same value. That is 120. That means that it is possible to find an unknown number of men, X, by multiplying it with the number of hours, which is 20, and equate it to this fixed value. Therefore, X is 6. 120 man hours is actually the time required to complete the job. We will now take a look at two problems. In the first problem, we have 12 men can complete a piece of work in 54 days. How long does it take 9 men to complete the same work? Once again, we begin with two statements which states that 12 men take 54 days. 9 men will take X number of days. As we can see earlier on, we use man days and the man days remains the same value. Therefore, 9x must be equal to 12 times 54 man days. Solving this, we have x equals to 72. We finish off with a statement, 9 men take 72 days. In the second part, we have 12 men take 54 days and X men takes 36 days. So once again, we multiply the men and the days, which will be equal 36x equal 12 times 54. And solving it, we have x equals to 18. The statement is 18 men take 36 days. In this example, we have 3 items. We have the number of men, number of houses, and number of days. To solve this kind of problems, we need to combine the men and the days. We begin by writing out the information. 5 men paint 2 houses in 3 days. And we are supposed to find how many days it takes 10 men to paint 8 houses in X days. Now, in order to solve the sum, we combine the men and the days. Therefore, we have 3 times 5, which gives us 15 man days to paint 2 houses. Similarly, man times the days, we have 10 man days to paint 8 houses. Remember that man days is the amount of time required for the job. So if we have more man days, we can paint more houses. That means this is actually a direct proportion. And for direct proportion, we form the ratio 15 over 10x equals 2 over 8. And solving this, we have 20x equals to 120, and x is equal to 6. Therefore, it takes 10 men to paint 8 houses in 6 days. Now we will see direct proportion using a constant value k. We use the previous example of the library fines. If we look at the table, we realize that 20 is actually 20 times 1, 40 is 20 times 2, 60 is 20 times 3. That means that the fine is actually found by taking a constant value 20, which we replace by k, multiplied by the number of days. Therefore, we say that when 2 quantities are in direct proportion, one will be a constant value times the other. We will now look at some more examples. In this example, we are looking at the total mass of n pieces of chocolates. As we know that with more chocolates, the weight will also be more. That means it is a direct proportion. As in the case of the library fines, that when 2 items are in direct proportion, then one will be a constant multiplied by the other. That is, in this case, n will be a constant multiplied by m. K is a constant. The question will give us some values to find out what is k. So when n is 15, m will be 180. Substituting into the equation, we have 15 equals k times 180. That gives us k equals 1/12. Having found k, now we know the equation. Which is n equals 1/12 of m. That is by substituting k into the original equation to get the actual equation. The last part of the sum requires us to use this equation to find other values. When n is 20, 20 will be equals to 1/12 of m. We substitute 20 into the equation and we can find the value of m. Let us now look at the processes involved. When we look at a sum, we must always take note of what kind of proportion it is. If it is direct proportion, then we will write the statement where 1 equals to the constant times the other quantity. So the first step is the k statement. Next, we need to find k in order to get the actual equation. So the second step is to find out the value of k by substituting the given values. The third part of the sum is to state the equation. And the last part of the sum is to use the equation to find other values. In the next example, we are looking at the mass of a square piece of glass and its length. As we know that when the length increases, the mass will also increase. Therefore, this is a direct proportion. And we are given that the mass is directly proportional to the square of its length. Let us consider the mass as m and the length as L. Therefore, the mass is equal to a constant value times the square of the length. K is a constant. Once again, we are given two values to determine the value of k. When the side L is 20 cm, then the mass m is equal to 1000 gram. Substituting, we have 20 square. And solving for k, we have k is 2.5. Therefore, we can now find the equation. Which is m equals 2.5 times L squared. And again, the last part of the sum requires us to use the equation when the length is 30 cm. Substituting, we have m equals to 2.5 times 30 squared, which gives us 2250. We end off with a statement. Mass of 30 cm glass is 2250 grams. We will now look at reciprocals before we begin the topic on inverse proportion using K. The reciprocal of 5 is just 1 over 5, and the reciprocal of 3/5 is 1 over 3/5, which is just 5 over 3. Therefore, the reciprocal is found by inverting the fraction. We use reciprocals to show inverse proportions because when we put the quantity in the denominator, when this quantity increases, the whole fraction will drop in value. This causes an inverse effect, which we will use in the next part of the lesson. We will now look at inverse or direct proportion using K. As we can see in the previous example on the number of men and the number of hours you work, that when we take the number of men multiplied by the number of hours, we always get a constant value, 120. That means if the number of men is M and the number of hours is T, then the number of men times the number of hours will give us a constant value. This can be written as M equals to constant over the time. This is an inverse proportion. We can see that the time is in the denominator, or we have the reciprocal of the time. Therefore, when the time increases, then the mass will drop in value. The mass is the whole fraction, so when the denominator of the fraction increases, the mass will drop in value. Therefore, we have an inverse proportion where if the time increases, the mass will drop. We now take a look at some examples. In this example, we are looking at a cup of water that is poured into a cylinder. The depth of the water is inversely proportional to the square of the base radius. As we know that when the radius increases, the depth of the water will drop. Therefore, this is an inverse proportion. As we can see here, it says that it's inversely proportional to the square of the base radius. So if the base radius is r, then the depth of the water will be equal to the constant over the square of the base radius. This is how we express the inverse proportion. remember that when the quantity is in the denominator and when the denominator increases, the other value will drop. K is a constant. The next thing to do now is to find K. There are values given for you to find K. Therefore, when the radius is 3, the depth of the water is 24. Substituting into the equation, we get 24 equals to K over 3 square. K is found to be 216. Once we have found K, then we will know the equation. Which is D equals to 216 over R square. And the last part is to find the depth when the radius is 6. Radius is 6. cm. Substituting into the equation, we have the depth is 216 over 6 square. The depth is 6 cm. Now we take a look at the second example. In the second example, we are looking at the intensity of radiation, I, which is inversely proportional to the square of the distance d. We write the K statement, I equals, since it's inverse proportional, therefore it is K over d square, square of the distance. State that K is a constant. And now to find K, when D is 6 meters, the radiation I will be 800 units. Substituting, we have 800 equals to K over 6 square. Right? This will give us K equals 28800. So now we have found the equation. Which is I equals K is 28800 over D square. And we have to find two values. The first one, we have to find the distance given the intensity. The intensity, when the intensity is 1800, then we substitute into the equation. 1800 equals 28800 over D square. That gives us 1800 D square equals to 28800. And dividing, we have D square is 16 and D is 4 meters. In the second part, we are given that when the distance is 10 meters, find the radiation. I will be equals to, use the equation, 28800 over d square, which is 10 square here, and that gives us 288 units. Finish off the sum with a statement. That is all for the topic. Thank you.